For this warm-up, you are going to find the constant of proportionality. Remember, to find k, we do y divided by x. So in this second one here, the y value is 1 and the x value is 3. 1 divided by 3 can be rewritten as 1/3. If we check another section in the table, 2 divided by 6 is also a third when it is reduced. So find the constant of proportionality for all of these. The constant of proportionality, or the unit rate, can also be applied to a new situation where we're talking about scale drawings. The scale factor is similar to a constant of proportionality. We are going to take one item, or one image, and scale it by a scale factor. Here I have an original picture of an elephant. 2 of these are scale drawings, and 2 of them are not. You'll notice that this first one here is stretched horizontally, but not vertically. Whereas this one is stretched vertically, but not horizontally. In order to be a scale drawing, we have to either stretch or shrink in both directions to make the image appear the same as the original, just a different size. There are 2 types of scale drawings. One is called a reduction, where we shrink the original figure, and one is called an enlargement. Here we have the giraffe. Which of these are scale versions of the original figure? A and D. A would be considered a reduction, and D would be an enlargement. In your book, it says to use the 2 figures of the school building to complete parts A through E. You're going to choose a segment in the original figure. Use a colored pencil to trace the segment in the original. So we're going to take, for example, these pieces, and we are measuring the segment in the original, recording that length in the table, which you'll see in the next part. And then we're using the same color for that scaled one and measuring that as well. You will need a ruler for this piece of the lesson. Keep in mind that since I'm using a digital ruler, your numbers are going to come out different than mine. Here you can see that segment is approximately 8 centimeters in the scaled version, and about 2.6 in the original. E says to complete the table by repeating those for another set of segments. So we'll take a new color and we're going to select another segment to measure. So for example, the height of the flagpole. Remember, your measurements will not match mine because I am measuring it on a computer screen and you are going to use the pages in your workbook. So the height of the flagpole for me is approximately 0.9 and 2.7. And then we need to repeat that for another section. For example, we can use the piece of the roof. The original is about 1.1 and the scaled version is about 3.3. What is the relationship between the lengths of the segments that are in the same location in the original figure and the scaled figure? Well, if we're dividing y by x, that's going to give us that scale factor. And when we divide, you can see that these scale factors all come out to approximately 3. So we're going to say the size of the segments in the scale figure are 3 times the size of the original. And you may notice that this one didn't come out to exactly 3, which could be an error in our measurement, like maybe we were approximately a tenth off, or it could be just that the picture is slightly mistaken. But we're humans, and we're measuring with a ruler that may or may not be perfect. So there's an acceptable amount for it to be different because it's a scale drawing and we're measuring as a person, not using something that's set up to give us exact answers. So it's okay that it's slightly different. We're just making a general assumption here, or a generalization. We're going to do the same type of thing with these pictures, choosing the segment, measuring the original and the scale figure, and writing them in the table. I've chosen the roof, the height of the door, and the height of the bench. After measuring, I have 3.6 centimeters and 1.8 from the scaled version, 1.4 in the original and 0.7 in the scaled version, 0.4 and 0.2 in the scaled version. So when I divide y by my x value, like we do with their constant of proportionality, this also tells us how to find the scale factor. And each of these, when dividing, comes out to 0.5, which is also known as a half. So the scaled side lengths, or scaled length, are half the size of the original. And you'll notice that a half made the scaled figure smaller than the original, but a scale factor of 3 made it larger than the original. What do you think a scale factor of 1 would do? We'll come back and add those to the notes in the debrief section. Let's look at this one. Pedro paired this side length of 12 with this side length of 5, the side length of 4 with the side length of 16, and the side length of 3 with the side length of 20. But you'll notice here, there's a right angle between the 12 and the 16, but not between the 5 and the 4. So it appears that Pedro may have mixed some things up. Instead, we would want the 12 to be paired up with the 3 to make that same right angle, and the 20 to be paired up with the 5. So Pedro made an error because he didn't match up the corresponding sides. If he did, 16 divided by 4 would be 4, 20 divided by 5 is 4, and 12 divided by 3 is also 4. So these are scaled versions of each other, but you have to be careful to pay close attention to matching up the correct sides with the corresponding sides. All right, so now let's discuss. A scale factor that's 1 makes the scale version the exact same size as the original. A scale factor that is smaller than 1, less than 1, smaller than 1, would be a reduction. You're reducing the size. And a scale factor greater than 1 would create an enlargement. With this scale factor of 1, it is important to keep in mind that we don't want negatives. So the scale factor is smaller than 1, but also bigger than 0. Because a scale factor of 0 would get rid of your picture altogether. So we don't want any negative scale factors. But fractions smaller than 1, like a half or a third, would create a reduction.